So we've all experienced the pain, frustration, hassle at one point or another of patchy or sometimes non-existent network connectivity. So maybe you've been out for a drive in a remote area of Australia, got your phone out, taken a photograph of the beautiful countryside that surrounds us, gone to share it with your friends on social media, and you can't because there isn't any network connectivity. And this is a problem that will occur in 70% of locations around Australia. The problem's not unique to Australia, and it's also not unique to the internet for humans. It's actually blocking the adoption of the Internet of Things. And bearing this connectivity issue in mind, we'll now take a look at the state of the art for water tank monitoring on a large farm. So this is Tom taking a very long drive to go and see how much water is in the tank on his farm. And he'll drive around the farm to do that throughout the tanks to get one very small but very important piece of information, which is how much water is in the tank. Because if the tank's empty, then the stock are hungry. And on a farm, the applications like this that need a very small amount of highly valuable data are certainly not limited to tank monitoring. We're talking about other applications like soil moisture probes, water flow meters, weather stations, all the way through to tracking of individual cattle themselves. And then if we look more broadly beyond agriculture, we can consider a whole suite of industry verticals that have mobile and remote operations and a need to get small amounts of highly valuable data. So this includes industries like utilities for gas, electricity, water metering, like logistics and asset tracking, preventative maintenance, maritime for vessel tracking and aids to navigation, and then monitoring our environment, groundwater levels, and on the ocean, and then a whole suite of applications within defence as well. And while these different verticals are quite different in their nature, they all have one thing in common, which is that they have this need to get a small amount of really valuable data back to a location, whether it's for tracking, sensing, and so on. The data might be small, but the benefit's huge. We're talking about bringing this data together. The problems it can solve are massive. When we look at the bigger picture here, we're talking about securing our food and water supply, securing our environment, and securing our people. At Myriota, we deliver Internet of Things connectivity everywhere. And we do this at an ultra-low cost, with very long battery life, in a secure and private way, and provide global coverage. And the way that we provide that level of coverage is to use satellites. And when many people think about satellites, they think of large, heavy, expensive spacecraft, like the one on the left here, costing hundreds of millions of dollars, weighing a lot and costing a lot of money to get out into orbit. In contrast, we use much smaller satellites, like the one on the right here, that weigh about 5 kilos and can be put on orbit, built and put on orbit for around $1 million. And we put them into a lower orbit where they orbit the Earth at roughly one time every hour and a half. So if we take a look at our journey and where we started, Myriota began in 2011 within the Institute for Telecommunications Research at the University of South Australia with support from the Australian Space Research Program. And what we did was we undertook a premeditated commercialisation. We identified a gap in the market, the need for this type of connectivity, and then we went out and we spoke to potential customers of the service. And those conversations went along the lines of, how often would you need to get your data? what size of message, how long would the battery need to last. All of these kind of requirements analysis questions that happened before we started to do the research. We then set about identifying and then solving the real deep tech problems here. So from a telecommunications perspective, there are a number of these. We developed the algorithms and the architectures and the solutions for them. We demonstrated those first in simulation, and then we took them up into aircraft trials to show them working in the real world. Based on the success of the aircraft trials, we then took them through to initial satellite trials. And we first validated this system with real satellites back in 2013. So the technology we're talking about here is very mature, and we filed patents protecting that technology that far back as well, and won some awards along the way. And based on that, in late 2015, we spun the company out. And we did this with the support of a Canadian company, satellite owner and operator Exact Earth, who provided the capital to get us started and also provided us with access to their LEO satellites. And then we set about taking those prototypes and the demonstrated working technology, transferring that into product, building the product and putting it into the hands of real customers for their POCs. We took on some more investment. We had paid proof of concept field trials with customers. We mitigated and we de-risked all of the technical risks and regulatory risks, and at the same time built our sales pipeline. In March last year, we closed a Series A funding round to grow the company, to build our sales pipeline further, and to expand our constellation. That was a $20 million round led by Australian financial investors, and also brought with it Boeing's Horizon X, with Boeing making their first investment outside of the United States, and Singtel Innovate. And then earlier this year, we appointed Pam Melroy as an independent director to our board. Pam has a huge background in space, having piloted and commanded space shuttle missions, as well as having held senior roles within defence and the US government. She's incredibly smart, connected and respected, and on top of that, a great person to work with. So we have a very strong board, and now we'll move on to talking about our system. So devices in the field communicate directly to our satellites. And this is a key feature of our system. They don't have to go via a ground-based piece of infrastructure first, which then talks to the satellites. The devices can be deployed everywhere and communicate directly to orbit. And our system and our algorithms have been designed to support billions of devices globally. The satellites capture these signals and then they downlink them via a ground station network through to the cloud. We then deliver the messages through to the end customer. So just putting some numbers on things here, billions of devices that can last in the field for more than a decade using batteries that you can purchase from your local supermarket, and a 10x cost reduction compared to the existing services. So in terms of price point, 1 cent to transmit a message through the system. Our module can be integrated into any product to give it this capability. So by adding this module onto a PCB and a small antenna, the device can then communicate directly via our satellite network. This has edge processing capability. It's got an ARM Cortex-M4 on board. It also has all the standard types of interfaces that you'll need to communicate with IoT sensors. It's been designed for long battery life, and it also has our communication stack on board, and it's accompanied by a very simple but powerful software development kit and API. The devices then communicate to our constellation of satellites in low Earth orbit, and you can see here our current constellation with 3 satellites that are in polar orbit. So they're passing over the poles, providing global coverage, and then complementing that with a satellite that's in equatorial orbit. These satellites provide global coverage, but doing this also comes with a number of challenges. So to start with, we're talking about devices where we're aiming to maximize battery life. So that means our transmitters are effectively whispering. And combining that with the fact that they're not talking to a base station that might be kilometres away, but they're actually communicating with a spacecraft that could be 2,500 kilometres away when it's out on the horizon, and the closest it's going to get to the device is 600 k's away when it's directly above. It's hurtling through the sky at 7.5 kilometres per second. So all of these things do quite some interesting stuff to the radio channel. And to make matters worse, we're not just having one device communicate with the satellite, but if you look at the size of this footprint here, that represents the surface of the Earth that the satellite receiver can see. And so that means that when the satellite is above Alice Springs, it can see the entire country of Australia. So you have devices in Broome, in Perth, Townsville, Hobart, all simultaneously communicating with the spacecraft. So that's a massive multi-user access problem. And we've innovated in a way that enables that massive scale access and very long battery life by doing very clever signal processing and very clever scheduling, very clever waveform design, and then using system architectures that enable all of these features for our end customers and adding end-to-end security and privacy on top of that as well. And so there's some really deep tech innovation here that covers everything from the algorithms and the architectures through the applications, and that we've filed across 21 patents. So what we're talking about here is a unique capability and differentiating technology. And then if we think about now, how do we join forces with AWS and how do we use AWS to take our solution out to market? Well, it's really about adding our unique capability and our deep tech onto the undifferentiated heavy lifting that AWS gives us. And we use AWS's cloud compute and storage, we use managed services, and recently the AWS ground station. So let's take a bit of a look at what I mean by that. Our satellites capture the signals as raw spectrum. They have an RF front end and they do an analog to digital conversion, and they take what they are hearing through to digital samples, and at that point they stop and they store that. And it's a store and forward system that then takes the outcome of that and then downlinks that spectrum via the ground station network into S3. So we're doing a direct-to-orbit capture of raw spectrum with a store and forward through to S3. And then what happens next is we invoke an event-driven data pipeline. The first step in this is the implementation of our software-defined radio. So this is where we do the advanced multi-user reception, where we unjumble that mess of all of these simultaneous transmissions, and we effectively turn raw spectrum, take that, and push out user messages out of this side. We do this by running our SDR using batch on EC2 and using Spot Fleet. And from there, we have a series of loosely coupled event-driven services. We move into event-driven lambdas for authentication. We track the messages through billing to perform our billing, and then we feed the messages via a message broker through to our customers via a RESTful API. So what this means for Myriota in terms of the advantages it brings, it gives us this ability to add our unique IP on top of this undifferentiated heavy lifting in a way that enables a really rapid transition from our ideas through to value that we can deliver to our customers. A key feature here is that we have a massively scalable communication system, but in terms of the implementation here, with the elastic scalability that AWS provides, that means we don't have to consider the capacity of that implementation up front. So we can just hit the ground running and get going. And then seeing the way AWS Ground Station as well follows the same philosophy of providing this on-demand access that's API driven, we can combine all of these things to deliver a very scalable and cost-effective solution. So taking another look at the verticals that we were talking about before, we'll have a look at what some of our customers are doing with our products and service in order to support their customers. So this is a proof of concept that we ran a while ago to put a tank monitor in the hands of farmers and see how they received it and the benefits that they drew from it. And you can see here that we had these tank monitors scattered around Australia. Very easy to deploy pressure sensor into a tank with a device that then transmitted the data back through our network and ultimately through to the farmer on their phone. And this saved farmers hundreds of kilometres driving. And on top of that, it also provided timely information back to them. So it wasn't once every few weeks, the next time they go for a drive to have a look at the tanks. It was multiple times a day they could see how their tank was going. And at one point, one of the farmers actually gave us a call because they'd noticed that their user interface had gone from blue to orange to let them know that the tank was near empty. And they were a bit sceptical about this because they'd seen it recently and thought there's no way that tank's empty. So they drove out and took a look at it, expecting this to be a software bug, but they actually found that the tank was empty. The pump had failed and they needed to fix it. So what was originally going to be a call just to let us know about a problem with the software actually became a call to say thank you, because it would have been weeks before that farmer had gone back out and seen that the tank was empty. And that was a warm time of the year and the stock would have been under stress throughout that period. And so for us at Myriota, when we get that kind of feedback from customers, that's massive, because that really hammers home the end value that we're providing to our customers and then to their users with the real world applications where it actually makes a difference here. Since that POC, a number of OEMs have taken our connectivity and added it to their products to support agriculture, like Davy Water Products with their Tank Sense monitor, like MEA, who have a suite of Green Brain products for a microclimate station, a tank monitor, and also for soil moisture probes. And they feed the data that comes from that into their front end so that they can give farmers insight into soil moisture in their Shiraz vineyard or weather information around the farm. And all of this is enabled by being able to get that small, high-value data from everywhere. And then moving beyond ag, we look to a number of companies that are developing products for preventative maintenance, like Ping. Ping have an advanced acoustic sensing that's able to detect issues with wind turbines. And they use Myriota connectivity to get the outcomes of that back to the end user. That way, the wind turbines can be repaired before it becomes catastrophic. We've been working with the Australian Institute of Marine Science since before we spun the company out. They use our connectivity for their oceanographic drifters, where that provides them with information on the currents, the temperature, the humidity, and the pressure out on the oceans. And similarly, we've been working with the Defence Science Technology Group for a long time as well. And a recent program with them, the Fight Recorder, records the motion of the warfighter for event reconstruction and also provides a personal beacon for alarms. Again, all of these applications are enabled by Myriota providing that connectivity for small amounts of really valuable data that will do everything from protect a wind turbine, protect the health of cattle, through to protecting the warfighter. And if we now take a look at beyond the module itself, we have a developer toolkit which has this module mounted on it on a developer board, along with the GPS and antennas, battery holder, and then an easy-to-use interface through to sensors. Everything you need to get up and running in the lab. Accompanying that is a satellite simulator. So this gives our customers the ability to run the system end-to-end in the lab, have the satellite simulator push the captures through to our network, and then have our RESTful API then push the messages back to the end customer. So everything in the lab. Then also, as part of the kit, is an enclosure. So once the application is tested in the lab, it can be taken outside to run the initial POCs before going to a larger scale. Part of this is our software development kit and our API that is really simple and really powerful and gives everyone everything they need to bring an application up really quickly. It has tracker examples how to use the resources on board the ARM Cortex-M4, and makes that edge processing and analysis that you might want to do on that processor of things like checking against thresholds of a sensor reading, these kind of things before you package up your message for transmission. Makes all of that very simple. And then for systems integrators who want to hit the ground running and go to their deployments quickly without having to build their own enclosure, we also have the Sense and Locate device, which has a rugged IP67 enclosure. It has a very easy to use universal mounting plate. Everything that we learnt from our POCs initially with customers we fed back into the design of this to make sure that it's really easy to use for the end user. It also has a 4 to 20 milliamp sensor interface with a gland at the base there for routing that through to make it very easy to integrate sensors, and it has onboard GNSS as well. So moving forward, we're growing our sales team, we're expanding our market footprint, we're building 3 more satellites which will be launched from the end of this year, and we're working towards a larger constellation, with the next step shown here being 30 spacecraft on orbit. Having the additional spacecraft reduces the gap in time between opportunities for the devices to communicate with the satellites. And once we get to 30, we're looking at a maximum gap there of in the order of 5 to 10 minutes. And then ultimately pushing out to 50 satellites in the constellation for near real-time coverage. And so by combining Myriota's unique IP to enable this with what AWS provides in terms of really scalable and cost-effective, undifferentiated heavy lifting, we're able to deliver IoT to our customers everywhere. Thanks.